మీ అమ్మ తాత ఎక్కడికి కనీసం ఆగే ఎవరితో మాట్లాడాలి ఏమకి చేవే
ఎందుకురా నీకు
పలకరివే
కాదురా మాయ ఆర్డర్ పెట్టాడన్నావు ఎదురా ఆర్డర్ కాపీ నీకు పెట్టాడా పర్సనల్ గా
గుడ్ మార్నింగ్ అమ్మా
నా నంబర్ ఇచ్చి నాకు వితేసి ఉంటాడు
ఇది 7981
హలో గుడ్ మార్నింగ్
దానికే అక్కడ ఫోన్ చేసేది కట్టెల
So in the last class, we have discussed about the normal stress and tangential stress on the oblique plane. And we have discussed about the principal plane as well as principal stresses. Principal plane and principal stresses. So how to calculate the principal stresses and how to calculate the principal angle we have discussed in the previous class. Using the same formula, that is considering the shear stress. Considering the shear stress on the principal plane is equal to 0. Then we need to find out the angle. We need to find out the angle and we need to substitute that angle. We need to substitute that angle in the normal stress. We need to substitute the angle in the normal stress to find out the only normal stress existing on the oblique plane. Only normal stress existing on the oblique plane. So we have derived it in the previous class, that are the maximum principal stress is sigma x plus sigma y by 2 plus root of sigma x minus sigma y by 2 whole square plus tau xy. And the minimum principal stress is, sigma x plus sigma y by 2. Instead of positive, we will have a negative for a minimum principal stress, and tau xy, that is sigma x minus sigma y by 2 whole root. This gives the maximum and a minimum principal stresses on the oblique plane where shear stress is 0. Where shear stress is 0. So this is the analytical method. So we have a graphical method. For finding the normal stress for finding the normal stress and shear stress on the oblique plane, and also to find the principal stresses applied on the oblique plane. So here the graphical method was derived by Mohr circle. The graphical method was derived by Mohr circle method. So here in the graphical method, we need to consider only two-dimensional axis, that is x as well as y. X as well as the y. So here the x value towards the right hand side need to be considered as a positive stresses. That is nothing but a tensile stresses. And towards the left hand side, we need to consider the compressive stresses. Towards the left hand side, we need to consider the compressive stresses. So this is a graphical method to draw the Mohr circle and finding the unknown, that is the normal stress, that is a normal stress sigma n, and the shear stress on the oblique plane, the shear stress on the oblique plane. So how to construct the Mohr circle to finding the problem? So the construction of Mohr circle is, if you see the diagram or if you see the problem, we have a sigma x, sigma y, and tau xy. So I need to represent all these values in my Mohr circle. I need to represent all these values in my Mohr circle. Therefore, draw a horizontal line. First of all, draw a horizontal line. Draw a horizontal line. Make a point A. Make a point A. Capital A, that is the origin for our, that is the y-axis and x-axis. The x-axis begins from A. It is a positive directions. It will be negative directions. If I have a compressive load, I need to take the left hand side of from A. From A, I need to take towards the left hand side. From A, I need to take towards the left hand side. So now I need to take the sigma x value. I need to take the sigma x magnitude in proper scale. In proper scale. That is nothing but we need to consider a scaling. It is a graphical method. I need to consider a scale. That is 1 centimeter in the scale is equal to some constant in Newton per mm square. That is this is the viewer value. మీ పేపర్ ఎంత లెంత్ ఉందో దాన్ని బట్టి ఈ స్కేల్ అనేది మీరు డిసైడ్ చేసుకోవచ్చు. ఇట్ ఈస్ అ స్కేలింగ్ ఫ్యాక్టర్. విల్ కాల్ as a scaling factor. Scaling factor. With this scaling factor, I need to find out the sigma x value, and I need to write the A and B points in centimeters. In centimeters of a horizontal line. Next, similarly, I need to consider the sigma y in centimeter with the same scale, and I need to keep the distance a point C with a scale from A only. So both points need to be taken from the A. The origin is A now. I need to take the value from the A. A to B is sigma x and A to C is sigma y. After keeping the sigma x and sigma y sigma x and sigma y, I need to draw a shear stress. I need to draw the shear stress on the body along the y-axis, along the y-axis. So I need to draw the shear stress applied on the body along the y-axis with the same scale, with the same scale, with the same scale. Therefore, I need to take the tau xy in centimeters. Height. So I need to keep E point. I need to keep a E point and I need to draw a perpendicular line from C. I need to draw a perpendicular line from C, and the height of that E is now tau xy in centimeters. In centimeters. Now, from B, I need to draw again the tau xy towards the downside, and I need to keep the point as F. I need to keep the point as F, and whose height of BF distance is tau xy in centimeters. That is with a scale factor, So here this height and this height will be same, because a body will feel a complementary shear stresses on the faces. Therefore, the magnitude of the shear stresses will be same. The magnitude of the shear stresses will be same. Therefore, we'll have the same heights. But which is moving upward direction at a C, which is moving downward direction at a B. Therefore, we'll have the heights. CE is also equal to BF, which is also equal to tau xy in centimeters. Next, we need to join EF line. Now, this line bisects our horizontal line. At O. This line bisects our horizontal line at O. Now, next step. From O and making an angle 2 theta from OF. At O, making an angle 2 theta from OF, draw a ray which cuts the circle at G. How to draw the circle, Amma? Taking the radius OE or OF. And making a center as O, and radius E, draw a circle. This circle will call as a Mohr circle. So the unknowns, total unknowns, 3 unknowns are now sigma x, known value I have represented here. Sigma y is a known value I have represented here. And tau xy is shown in E to C and B to F. So these are the three known values. And another known value is there in our body, ama, that is nothing but angle. That is nothing but angle theta. Angle theta is a known value now. So I need to represent the theta also in my Mohr circle to find the normal stress on the oblique plane. So here, how to draw an oblique plane, that is angle. So here I need to consider 2 theta ma. In the body we'll have only theta. In the body we'll have only theta, but in the Mohr circle, we need to consider 2 theta. We need to consider 2 theta at an angle which is at a point O, and making an angle from OF, and draw a ray OG. Extend this ray. I had the angle now. With this angle, making a point O, draw a ray and extend the ray which cuts the circle at G. Extend the ray. I know the angle only. I don't know the length. It is nothing but a radius again. OG is also a radius because it is also a outside point. G is also an outside point of the circle. We have outside points G, E and F. And origin of the circle is O. So here we have found the G point. Now draw a vertical line. That is nothing but perpendicular to AB line. That is horizontal line ki perpendicular ko vertical line giyali, which passes through G. And it cuts the horizontal line. At a D. Which cuts the horizontal line at a D. Now measure the distance from A to D. It gives the normal stress in centimeters. If I measure G to D, if I measure the distance between G to D, it gives the shear stress on the oblique plane. In centimeters. But our problem requires in Newton per mm square. Therefore, I need to use this scale. Whatever you have used in previously, and I need to convert how much centimeters. It may be 1.2 centimeter or 1.8 centimeter. So I need to convert this using this scale, and I need to find out the magnitude, that is the shear stress magnitude or normal stress magnitude, by using the same scale whatever we have considered for drawing the sigma x and sigma y and tau xy. So this is the procedure followed for the graphical representation of the oblique plane we will call as a Mohr circle method. We will call as a Mohr circle method. So here we have two types of methods to analyze the normal stress and shear stress on the oblique plane. So here with this, the chapter 3 in the first unit is closed. So chapter 3 in the first unit is closed, Rama. So we need to do some problems. So here read the problem 1. The stresses at a point of a bar are 200 Newton per mm square. He is telling it is a tensile, and 100 Newton per mm square a compressive. Determine the resultant stress in magnitude and direction of a plane inclined at 60 degrees to the axis of major stress. Axis of major stress. This is the first case. So here we have two axes. Here we have two axes. That is sigma x. Along the sigma x we have one axis. Along the sigma y we have another axis. Always while deriving the derivation we have considered the theta. We have considered the theta at this region. That is, we are considering the angle. We are considering angle theta. To this phase. So if I draw a inclined line, therefore the same theta can be observed along the y-axis. That means here the y-axis is a minor. It is a minor, and this is sigma x is the major axis. Minor and major axis. Therefore, in the problem, please read the problem, Ma. A plane inclined at 60 degrees to the axis of major stress. So what is the theta he had given? Whether he had given the theta or some other angle he had given, we need to observe this. He are telling that an inclined plane is making an angle of 60 degrees with the major axis. This is the major axis, and he is telling this angle. It is 60. He is telling this angle, but we had derived the relation for the normal stress on the inclined plane. This is the angle. మనం ఈ యాంగిల్ ని పెట్టుకొని మనం డెరివేషన్ చేసాము. This is the angle we have used for deriving it. But మన problem లో ఇప్పుడు this is the major axis. This is the inclined plane. So he is telling 60 degrees. It is making a 60 degrees for the inclined plane with the major axis. with the major axis stress. With the major axis stress. Therefore, the theta will be 90 minus 60. It is equal to 30 degrees. The theta will be 30 degrees. So, first we need to find out the theta. Whether he had given directly or indirectly, we need to see it and we need to find out the theta. And after finding the theta, he is asking the resultant stress on the inclined plane. The resultant stress on the inclined plane. How to find the resultant stress? How to find the resultant stress? So here on the inclined plane, we have normal stress, that is sigma n, and toward the parallel to the inclined plane, we have a shear stress. We have a shear stress tau capital X and tau capital Y. Therefore, I need a resultant stress for the both of this. That is sigma r. That is nothing but a sigma r. I need the resultant stress for this. He is asking that stress. For finding this stress, I need a normal stress on the inclined plane. I need the shear stress on the inclined plane. So by using the analytical method, we have an equation that is sigma x is a known value now. Sigma x is a known value. Sigma y is a known value, but it is a compressive. Therefore, I need to take as a negative sigma y. It is a compressive. Therefore, I need to take as a negative because we had derived the derivation by considering both as a tensiles. We had derived the relation by considering both as a tensile stresses. Sigma x and sigma y both are tensiles. But in the problem, we had derived it, we had considering that sigma y as a negative. Therefore, I need to substitute the value as negative. Next, we have found the theta value, that is 30 degrees. Had given the tau xy or not. The tau xy is not given in my problem, therefore it is 0. The tau xy is not given in my problem, therefore it is 0. Therefore, substituting all the values, that is sigma x is equal to 200 and sigma y is equal to minus 100 in my equations, and theta is equal to 30 degrees. I can find the normal stress and shear stress on the inclined plane. Shear stress on the inclined plane. Next, after finding these two values, I need to find out the resultant stress. So now, this is the inclined plane. This is the normal stress. Which is perpendicular to the inclined plane. And we have a shear stress which is parallel to the inclined plane. So we have a normal stress and tau xy, which are both perpendicular to each other. Now I need the resultant. stress. How to find the resultant stress? Using a vector formula. The resultant stress is nothing but root of normal stress whole square plus shear stress whole square. Simply like a triangle. It is simply like a triangle. Simply like a triangle. It is simply like a triangle. So with this manner, I need to find out the resultant stress in the component. I need to find out the resultant stress in the component. And the second case in the problem, also determine the maximum intensity of shear stress in that material. Maximum intensity of shear stress in that material. So here we are not applying any shear stress on the faces. Here we are not applying any shear stress on the faces, but on the inclined plane, the shear stress are developed. So he needs the maximum shear stress. He needs the maximum shear stress. At which angle? At which angle? I need to tilt the angles. I need to tilt the angles. That is, the angle theta is equal to 0, angle theta is equal to 1, angle theta is equal to 2, such that at a certain angle, we have a maximum shear stress. That is, a tau xy will be a maximum. Tau xy will be a maximum. Tau xy will be a maximum. So to this, we need to derive small equation, that is differentiating the tau xy and equating to 0, and we need to find out the angle 2 theta. We need to find out the angle 2 theta and substitute the 2 theta value, that is sin 2 theta and cos 2 theta values in the shear stress equation again. In the shear stress equation, that is nothing but sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. In this equation, I need to find out the sin 2 theta and cos 2 theta and substitute it again, and I need to derive an equation. The equation derivation will be similar like a maximum principal stress. The equation derivation will be similar like a maximum principal stress. The answer will be a root of sigma x minus sigma y by 2 whole square plus tau xy, that is the maximum shear stress. Maximum shear stress that is applied in the component. There is a formula we need to apply at that position. There is a formula, no need of this value, There is no need of this value. We need to consider only this side, that is sigma x minus sigma y by 2 whole square plus tau x whole square. So this formula need to be considered. At that position, and we need to find out the value of the maximum shear stress that can be applied in the component. Next, the same problem using the Mohr circle method. We can derive the same answer. we can derive the same answer. So here, the first step for the Mohr circle method is considering a scale. Considering a scale, that is 1 centimeter is equal to 1 centimeter is equal to 20 Newton per mm square. It may be a 20 or 10 according to your drawing sheets, that is your notebooks. According to your notebook size, you can take the size. So therefore sigma x he had given us 200 Newton per mm square tensile. Therefore 200 divided by 20, we will get a 10 centimeters, which is the distance of A to B. And second value sigma y is 100 he had given. So 100 by 20, which is a compressive in nature. Therefore it is 5 centimeters. The distance is AC. We need to consider as AC. And tau xy is not given in my problem. Therefore, it is 0. Therefore, BF and CE is also equal to 0. So the procedure begins again. Draw a horizontal line. Draw a horizontal line first. Make a point A. From A to B. Because here AB is a tensile. AB is a sigma x, which is a tensile in nature. I need to consider in the right hand side. Whose length is 10 centimeter. A to B. Next, I need to make a point C. Towards the left hand side. But because the value of sigma y is a compressive in nature. Therefore, the C will be seen here towards the left hand side of my A. Therefore, after making C and B, next step, what is the next step? I need to make a point of E and F. I need to draw a perpendicular CE. I need to draw a perpendicular CE of height tau xy. Since the tau xy value is 0, therefore the height of E and C will be having the same point. C and E will having the same point. At B, I need to draw a vertical downwards. But here also the tau xy is also equal to 0. Therefore, the F and B points lie on the same points. Next point is I need to join the perpendicularities and I need to find out the center of the point. That is the procedure. So I need to join E to F. And I need to find out the O. Now E is on the horizontal plane and F is also on the horizontal plane. Therefore, I need the distance between E to F. Now the distance is 15 centimeters. Now the distance between E to F is 15 centimeters. Now I need the O at the center. I need the O at the center. That is 7.5 centimeter and 7.5 centimeter from F and from E. So with that, I need to draw a point which distance is 7.5 centimeter from E and which is a distance of 7.5 centimeter from F. Next step is with the radius of OE, with the radius of OE, with the radius of OE, draw a circle. With the radius of OE, draw a circle. Draw a circle. So, considering a center at O and considering the radius E, OE or OF, OE or OF, draw a circle. This circle will call as a Mohr circle. This circle will call as a Mohr circle. After drawing the circle, after drawing the circle, I need an angle that is 2 theta. So in the problem, I had given the theta as 30 degrees. In the problem, I had given that angle, the inclined plane angle is 30 degrees. Therefore, 2 theta is 60 degrees. Now, in the derivation, we have considered the O to F and we have drawn an angle theta from O to F. Now O to F is in horizontal plane. O to F is in horizontal plane. Therefore, I need to consider 2 theta, that is 60 degrees. Now in problem it is 60 degrees. So from O and it is making an angle of 60 degrees from the O to F, from the O to F and draw a ray cuts the circle at G, which cuts the circle at G, which cuts the circle at G. Now from the G, draw a perpendicular. From the G, draw a perpendicular which cuts the horizontal line, which cuts the horizontal line at D, which cuts the horizontal line at D. Now measure A to D. Now measure A to D length in centimeters. In centimeters. Measure A to D length in centimeters and multiply with this scale whatever we have taken. Multiply with the scale whatever we have taken, that is if I got the value as 2.5 centimeter into 20, we have considered the scale as 20, therefore 2.5 into 20. Initially we have considered the scale by converting this to convert this. So 2.5 into 20, it may be 2.5. I am considering it as a 2.5. Okay, Nama? The answer will be varying. You need to measure from A to D with a graphical representation by a scale. And we need to multiply with the scale factor. We need to multiply with the scale factor. Therefore, we'll get the answer of the normal stress. They are measuring the normal stress on the oblique plane. If I measure the height of GD, if I measure the height of GD, If I measure the height of GD in centimeters, I need to multiply with the scale we have taken. I need to multiply with the scale you have taken. Therefore, we'll get the answer in Newton per mm square. This is a normal stress. This is a normal stress on the oblique plane. If he needs the resultant, if he needs the resultant, join A to G. Join A to G and measure it. And measure it. And measure it in centimeters. In centimeters and multiply with the proper scale. We have considered this scale as 20. Therefore, the resultant stress will be something in Newton per mm square. This is the resultant stress what we need to find in the question. Next, he is asking the angle of the resultant. This is the angle amount. The angle of the resultant. It is a graphical representation. Therefore, I can measure the angle by a protractor at A. And the ray is this. With a horizontal, what is the angle? Measure it. That gives the resultant angle. That gives the resultant angle. If we ask the resultant angle also, we can find by a graphical method the resultant angle. And next, the second case, he is asking the maximum shear stress. The maximum shear stress that can be attained in the inclined plane. So what is the shear stress here? What is the shear stress here? The shear stress is, this is the height on the inclined plane. This is the shear stress. This is the height. So if I rotate this angle, I can a tendency to rotate now, Amma. So if I rotate this angle, so the shear stress will be increasing and increasing and increasing up to O. Therefore, the G point and D point lies at this position. At that, again, if I rotate it, the angle is increased, then the shear stress is reducing again. The shear stress is reducing again. Therefore, if you see this tendency, we are getting the maximum shear stress. The maximum shear stress at O. We are getting the maximum shear stress at O. That is nothing but the angle 90 degrees. The angle will be at 90 degrees. And what is the value of tau xy maximum? It is nothing but the radius. Radius of the circle. Radius of the circle. It is nothing but the radius of the circle. So I can find the radius of the circle, Amma. That is nothing but O to F. O to F, it is nothing but 7.5 centimeters into scale. I consider the 20 as a scale. I have considered the 20 as a scale factor. Therefore, multiply with that. I will get maximum shear stress. Maximum shear stress that can be achieved on the inclined plane when the angle can be rotated. That is the maximum shear stress that can be achieved. So with this, the answer what we need to find here is derived. So second problem I'm giving as a homework, Amma. Second problem I'm giving as a homework. Please read the problem, Amma. A point in a strained material is subjected to the stresses as shown in the figure. locate the principal planes, and principal stresses. Find the principal stresses. So here it is not a standard format. It is not a standard format. The stress is certain inclined. The stress is certain inclined. It is making an angle of 30 degrees. It is making an angle of 30 degrees. So I need to resolve the inclined stress. I need to resolve the inclined stress which is parallel to that face and perpendicular to that face, which is parallel to that face and perpendicular to that face. How to resolve it? Engineering mechanics we have learned it, Tama. So now this is the force. I had given this 30 degrees. Sorry, 60 degrees. So I need to resolve this. This is the resultant. So I need to resolve it to the perpendicularity as well as to the tangentiality. So the angle here will be 30 degrees. Therefore, we will get resultant to the angle that is cos 30 degrees, and the resultant stress sine 30 degrees is the shear stress. Now I know this sigma x, which is nothing but the value 60 cos 30 degrees, and tau xy is 60 sine 30 degrees. And he had given that directly sigma y. There is no angle in between that. So it is 40. It is 40. Therefore, we know that a complementary shear stresses will be developed. A complementary shear stress will be developed on all the faces. A complementary shear stress will be developed on all the faces. Therefore, the problem now becomes a standard problem. But if you see the problem, he is not giving the angle theta. Sir, he is not giving the angle theta. How to find it? Sir, in the principal stresses equation, there is no angle amount. In the principal stresses equation, there is no requirement of angle. There is no requirement of angle in the principal stresses equation. We need to find out the angle by using a tan 2 theta, what we had derived in the previous classes. We need to find out the theta value. that is the analytical method. That is the analytical method. That is the analytical method. How to find by a graphical method? How to find by a graphical method? The procedure will be same, Amma. The procedure will be same. We have sigma x, sigma y, and sigma tau xy also. We have sigma x, sigma y, and tau xy also existing. So convert this into a proper scaling. Convert this into a proper scaling and draw a horizontal line and make a point AB and BC. The same procedure need to be considered. Here all are in tensile in nature. All are in tensile in nature. Therefore, we need to consider on the right hand side only. We need to consider only right hand side only. AC and BC also need to be considered on the right hand side. And next, we need to consider the shear stresses tau xy, upward direction and downward direction. The tau xy is also existing now. Now I need to draw a circle. Now I need to draw a circle. I need to draw a circle with a radius of OE, with a radius of OE and or OF. Sir, next step we cannot do it now in the Mohr circle method. Next step we cannot do because we are not having a angle. Sir, how to find the now? How to find the principal stresses? So to find this principal stresses, now measure A to N, that is circle cutting point on the horizontal line, is a maximum principal stress. Maximum principal stress. And A to M, A to M is the minimum principal stress. Sir, how to get this? How you can explain this? So in the derivation, I am considering this as shear stress on the inclined plane. I am telling that what is principal stress? The shear stress need to be zero. The shear stress need to be zero. That is the height of this need to be zero. So it will be at this position and it will be at this position. The shear stresses will be zero at the circle meeting horizontal points. So I am getting the maximum normal stress. The maximum normal stress. This is the maximum normal stress, and I am getting the minimum normal stress. Minimum normal stress at this position. So with this, just a simple drawing a circle and measuring A to M and A to N, I can find the principal stresses by using the graphical method. So derive and find both the problems. So screenshot this problem ma. The problem screenshot తీసుకుని problem solve చేయండి by two methods. రెండు methods లోనూ solve చేయాలి. Analytical method as well as graphical method. Analytical method and a graphical method. So this is the first problem. So make a screenshot. So with this, I am concluding the section.